Time travel. I mean, we've all seen it in the movies and read about it in books, right? It's this idea that has captured our imagination for, well, forever. But what happens when you strip away the fiction? Is there any real science behind it? Well, in this explainer, we're going to do just that. We're separating the fantasy from the physics. Just think about it for a second. What if you could actually go back? You could witness history being made, maybe have a chat with a figure like Leonardo da Vinci. The power to travel through time would completely change everything we think we know about the world and even about ourselves. And this isn't some new idea. For centuries, the question of time travel has sparked endless debates, inspiring incredible stories, and, believe it or not, some pretty serious scientific thought. It really taps into our basic human need to understand our place in the grand scheme of things. Okay, but here's where we have to hit the brakes on the Hollywood stuff. As cool as those stories are, what we're focused on here is the scientific reality. So, what do the actual laws of physics have to say about hopping around in time? Let's start with the direction that might actually surprise you. According to modern physics, traveling into the future, it isn't just a fantasy. It's considered scientifically plausible. And the key to this whole incredible idea comes from the one and only Albert Einstein. His theory of relativity didn't just tweak our understanding of the universe, it blew it wide open, showing us that space, gravity, and time are all tangled together. The main concept here is something called time dilation. And trust me, it's a real mind-bender. It basically says that time isn't this constant universal clock ticking the same for everyone. Nope, it's relative. Your experience of time can literally slow down compared to someone else's. So how does that work? Well, it happens in a couple of ways. First, speed. The faster you rocket through space, the slower you travel through time. If you took a trip at nearly the speed of light, you might only age a few years, while decades fly by back here on Earth. Second, there's gravity. The more intense the gravity, the more it warps space-time, and the slower time ticks. If you could hang out near a black hole, time would practically grind to a halt for you. And get this isn't just some crazy theory on a blackboard. Time dilation is a proven measurable thing. We've seen it in astronauts who come back from space just a tiny fraction of a second younger than they would have been. Even crazier, the GPS in your phone has to constantly correct for time dilation to work properly. It's real-world science that you use every single day. Okay, so traveling to the future, scientifically, it's on the table. But that leads to the big question, right? What about going backwards? This is where things get way, way more complicated, and we run into some huge, maybe even impossible roadblocks. You see, going back in time isn't just a tough engineering problem. It attacks the very foundation of cause and effect. The biggest hurdle by far is the risk of creating a paradox, a logical knot that seems to make the whole idea of past travel completely self-destruct. And the most famous example of this, the one you've probably heard of, is the grandfather paradox. It's the perfect thought experiment to show you why going back in time is such a logical nightmare. Okay, here's how it plays out. Imagine you build a time machine and go back to when your grandfather was young, before you met your grandmother. And, for whatever reason, you prevent them from ever meeting. Well, that means your parent is never born, which of course means you are never born. But wait, if you were never born, then who went back in time to stop them from meeting in the first place? It's an impossible loop that just cancels itself out. Now, to be fair, brilliant physicists have kicked around some wild ideas to get around this, like using theoretical shortcuts through space-time called wormholes, or something called closed time-like curves. But right now, these ideas are stuck in the world of math and imagination. They're fascinating to think about, but we have zero evidence they actually exist, let alone that we could ever use them. So, after all that, bouncing from the possibilities of the future to the paradoxes of the past, where do we actually stand today? What's the final verdict on time travel? Well, based on everything we know right now, all our science, all our technology, the answer is pretty straightforward. As of today, time travel just isn't possible, especially not to the past. So let's just boil it all down. The bottom line is this. Traveling to the future? It seems like it's allowed by the laws of physics, all thanks to time dilation. But traveling to the past? That seems to be blocked by these massive, unsolvable logical paradoxes. So for the time being, the time machine has to stay where it belongs, firmly in the world of science fiction. But maybe whether we can actually build one isn't the most important thing. The fact that we even ask these questions, that we use science and our own creativity to explore the nature of time itself, that says something pretty powerful about our curiosity and our incredible imagination.
Which really leaves us with one final thought for you. What do you think? Are these paradoxes absolute, unbreakable rules of the universe? Or are they just puzzles that we haven't figured out how to solve? Yet. Is time travel destined to be a dream forever? Or is it a future that's just waiting for us to unlock it?